Now we are going to begin one of the most interesting topic, that is the ECG. As well as ECG, we are going to see about one more newer concept, that is the bundle of his electrogram. It is a separate thing. After finishing ECG, we'll be discussing that. So coming to ECG, what is ECG? Everybody knows that it is electrocardiograph. Electrocardiograph. It is also called as electrocardiogram. Both are same. ECG is the common term for both of it, and we all of us know that it was invented by the scientist that Wilhelm Einthoven. And ECG, we are recording the electrical activity of the heart. But as such, we are not putting the electrodes over the surface of the heart. We are putting in the peripheries. How come our body is able to conduct through it? Because all our body is made up of various substances and ionic conduction is possible. So whenever any electrical activity is going on, that will be generated and it will be spread to the surface. That's how we are able to record the ECG in the surface and EEG in the scalp region. So our body acts as a volume conductor. Our body acts as a volume conductor. So that is the basis of ECG. About ECG, once you understand the basics, then understanding all the clinical applied aspects is very easy. Then normally we are recording a classical 12 lead ECG. In those 12 leads, whenever we are putting the electrodes on the patient, we don't put all the electrodes, or some of the calculations are done by the ECG machine itself. So basically the major leads are three standard limb leads. There are three limb leads, and these leads are called as bipolar leads. They are bipolar, and I will tell you what is the reason behind this bipolarity. Then there are three augmented leads. Augmented leads. For this three augmented leads, we don't put any electrodes at all. It is automatically calculated by the machine itself. So, but they are unipolar. They are unipolar. And there are six chest leads. There are six chest leads. Why do we need these many leads? And the chest leads are also unipolar. Why do we need these many leads? We need these many leads because we are trying to picture the heart from various different angles. It's like a movie only. We are shooting it from various different angles so that we get more information about the various walls of the heart, and then we can identify which region of the heart is affected. So that is the reason we have these many ECG leads. Then coming to this bipolar leads, what is bipolar leads? Bipolar leads means it will record the potential difference across two different regions. Suppose for example, in lead 1, we are placing it in the right arm and one is placed on the left arm. It will record the potential difference between these two leads. So that is called as a bipolar lead. Bipolar lead means there are two leads and it is recording the potential difference across the two leads. In unipolar leads also, unipolar is not completely unipolar. There will be one exploring electrode and the other electrode will be connected to a high resistance. So if I give high resistance to the other electrode, there will be no voltage recorded from that. So it is just an exploring electrode which is recording the potential. It is also a kind of bipolar, but since one end is connected to a high resistance ohm, it is called unipolar because it will pick potential only from this particular region. So that is called as unipolar. Unipolar, what do? We connect it to high resistance, that is 5000 ohm on one side. On other side, there will be an exploring electrode. Whenever we are picturing the heart, some of them are picturizing that in the horizontal section, like in this section. What leads are picturized in the horizontal section? The chest leads. Whatever chest leads we are putting it, they are taking the pictures of the heart in the horizontal section. And some of the leads are taking the heart picture in the vertical direction. So horizontal leads are formed over 6 chest leads, whereas the vertical picture are formed by our limb leads and augmented leads. Limb leads and augmented leads. So this is all the basis of ECG connections and everything. Now coming to the basis of recording the electrical potential. How the electrical potential in an ECG are recorded. First thing is, whatever instrument that is there inside the ECG is nothing but a simple voltmeter. It is an advanced version of a simple instrument called as the voltmeter. So there is an voltmeter which is recording these potentials. And we have to know some of the properties of voltmeter so that we can understand how the ECG waves are generated and what is the significance, why there is an upward deflection, why there is a downward deflection, and everything else. This voltmeter is usually connected to the two ends. What they will do, they will have some terminal like negative terminal and a positive terminal. And whenever any potential difference is recorded across these two terminals, what it will do is it will deflect. it will deflect and show us two things. One thing is the amplitude, like how much potential is being generated, how much height is the wave deflected. The second thing that is going to deflect is the direction, whether it is in an upward deflection or a downward deflection. Upward deflections are called as positive and downward deflections are called as negative. So what does the voltmeter do? It deflects two things. One is the amplitude. It is going to help us in calculating the amplitude. Suppose if the musculature is more, then obviously it is going to produce a more amplitude. Second thing, it is going to produce a directional. So both amplitude and direction will be recorded. So that is why it is recording the vectors. I will tell you more about vectors. So first, some basic rules of this recording potential. So what happens whenever the potentials are traveling towards a positive terminal and negative terminal? For example, if we have a membrane like this and all of the membrane inside is usually negative, RMP is negative, and whenever any impulse is generated or a pacemaker is generating some impulse and it is converting it and changing the potential. So if it is converting the potential, so what is happening? Now I am converting this potential to positive. All this negative I am converting into positive. And see the direction. In our example, the positive waves are moving towards a positive electrode. So what will happen? The deflection also will be positive. It is pretty simple. Whenever the positive electrodes are moving towards the positive, then our deflection will also be positive. So this is point number one. Second thing is, what happens when negative ions are traveling towards a negative electrode? For example, if negativity is traveling towards the negative terminal, negative ions are traveling towards the negative terminal, then also the circuit is going in its own direction, like it is in a proper direction. So the circuit will be complete and it will also give you a positive deflection. It will also give you a positive deflection. Whenever the reverse happens, for example, a negative electrode, negative change of potential is going towards a positive, or a positive change in potential is going towards a negative electrode, then also then both in both the cases the deflection will be negative. We will give a negative deflection. It is just like our basic max. Positive into positive gives us positive. Negative into negative also gives positive. Whenever it is reverse, we give a negative deflection. This primary understanding forms the basis of the entire ECG. And one more thing to note here, whenever charges are completely in one state, for example, there is no movement. We are starting with our positive changing the ions, and finally every ions are in the positive state. Now no current is flowing, now no deflection is happening. So whenever no current is flowing, but all the membrane is depolarized or repolarized in a single state, what is going to happen? It is not going to produce any kind of potential. So what the voltmeter will do? The voltmeter will give a flat recording. The voltmeter will give a flat recording. So these are the important points.